Good evening, everyone. Am I audible? Hope you are able to see my screen. Is my voice clear? Am I audible properly? Hi all. Welcome to the first live session of Digital Testing with Verilog. Let me introduce myself first. My name is Bijin Ansa Bibi. I am a PMR research scholar from IIT Palakkad. And I would also like to have a quick introduction about you. You can just type your name and your year of study. You can put it in the chat box. So most of them are from third year. Okay. Let's get started. I will quickly go through the logistics of the live session. I will be handling live session on every week, Sunday, 6 to 8 p.m. I think there are multiple live sessions you can attend based on your convenient time. And in this session, the first half an hour, we will have a quick recap of the important topics. And after that, we will have the problem solving sessions. The sessions mainly focused on the assignments of each week. And these problems will be similar to your assignments, not the same questions. It will be from the previous year questions. And time will be provided to solve each problem, and you can post your responses in the chat box. And if you have any doubts from the course content, you can also post it in the chat box, or you can ask me at the end of the live session. And after the live session, we will provide the slides and the recordings through a sheet, which will be shared by the NPTEL team. It will be available in the course page. You can access from that. And coming to the syllabus of this course, the first half will be mainly the number systems, switching algebra, Boolean algebra, and logic minimization, the combinational logic blocks, and how we can use Verilog for designing the combinational logic blocks. And the second half is all about the sequential circuit design, flip-flops, FSM registers, the state machines, and all. At last, we will have the basics of FPGA architecture as well. So this is the syllabus. I hope you all have watched the week 1 videos. Have you all gone through the week 1 content? Have you all submitted the assignment as well? The main focus of this live session is help you to solve the current assignments. We will solve problems which are similar to the present assignment. So we can have a quick recap of some important topics. Let's start from the number system. Computers usually understands the information composed of zeros and ones. In the real world, the information is analog. It is in a continuous form. But when it comes to digital system, it cannot take the analog data. It can take only the digital data. So it can understand information composed of zeros and ones. It should be in a binary format. And the number system is defined by three main characteristics. The first one is radix or base, that is the number of independent digits used in the number system. And the second characteristic is place value, that is the value of each digit depends on its position. And the third characteristic is the maximum number. That is the maximum number which we can represent with the given number of digits. So these are the various number system. First one is a binary number system. The radix value is 2. It can represents digits 0 and 1. And next number system is decimal number system. Usually programmers use decimal number system, but the system needs binary number system. So we will have the converters to convert from one number system to other number system. We will do the number system conversions. In decimal number system, the radix value is 10. It can represent digits from 0 to 9. And octal number system, the radix value is 8 and it can represent digits from 0 to 7. Hexadecimal, the radix value is 60 and it can represent digits from 0 to F. Let me show few examples of number system. First one is binary number system. For binary, the radix value is 2. So how we can represent this binary in positional number format? 1 into 2 raised to 3 plus 0, 2 raised to 2 plus 0, 2 raised to 1 plus into 2 raised to 0. So units plates, then tens, hundreds. So after decimal, it will be 1 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 1 into 2 raised to minus 3. Next, decimal. Here the base value is 10. 7 into 10 raised to 3 plus 3 into 10 raised to 2 is 9 raised to 1 plus 10 raised to 0. Similarly, for octal, here the base value is 8. 5 into 8 raised to 3 plus 6 into raised to 2 plus 3 into 8 raised to 1 plus 2 into 8 raised to 0. For hexadecimal, how we can represent this hexadecimal number in positional number format? You can put your response in the chat box. Here for hexadecimal, the radix is 16. So how we have written for binary, decimal, octal, similarly we can write it for hexadecimal. Yes, that is correct. 3 into 16 raised to 2 is F 16 raised to 1 plus 3 into 16 raised to 0. If this number has fractional part, then it will be into 16 raised to minus 1 plus 2 into 16 raised to minus 2. So this is how we can represent the number system in positional format. Now let's move to logic gates. Logic gates are the basic building blocks of digital systems. What are the logic gates? For, and, not, NAND, NOR, so, XNOR. Or is a binary operator. It has two inputs, A, output will be A or B. Next is AND, that will be A and NOT is a unary operator. It has only one input. A, then output will be the complement of the input. This is XOR. We'll come to this. NOR. NOR is the complement of OR. A, O, B, all complement. then NAND. Complement of AND. So XOR AB, I will be A complement B plus B complement A. Then XOR will be A complement or AB. Out of all these logic gates, what are the universal logic gates? Put your answers on the chat box. NAND and no. That is, we can create other logic gates function with NAND and NOR alone. So that's why it is called universal logic gates. Now let's move to the important properties of switching function. First property is the commutative property. That is x and y, that will be equal to y and x. Similarly, x or y is equal to y or x. You can put some values and check for x and y. Write all the input combinations, then x or y or x, 0, 1. Now both are equal. LHS equal to RHS. So if you do AND or OR operation, the commutative law x and y equal to y and x. Similarly, for OR, x or y, that will be equal to y or x. Next is the associative property. X and y and z equals x and y z. Similarly, if you have more than two inputs, more than two variables, either you can do the AND operation with y dot z first or x and y first. Either way you can do it. Both the sides will be same. LHS will be equal to RHS. Similarly, you can do it with the OR function. Either you have to do the y or z first or z or y. You can put some values and check whether LHS is equal to RHS. This is another important property. Next property is the distributive property. Distributive property, x and y or z, we can do it x and y and x and z. Then after that we can or both the x and y and x and z. Similarly, you can replace the and operator with or and or operator with and. You can apply the same property. So y and z will be inside the bracket. So it will be like x or y and x or z. This is the distributive property. Next is the absorption. That is x or x and y is equal to x. So if you take the LHS side, x or x and y, here the x is common. So x, if we take x as common, then it will be 1 plus y. That will be 1 plus y will be 1. So it will be x dot 1. That will be x. This 1 plus y, if you take y value as 0, y plus 1 will be 0 plus 1. That will be 1. If I take y value as 1, then it will be 1 plus 1. That will be 1. So y plus 1 is equal to 1. That's how here 1 plus y equal to 1. X dot 1 will be equal to x. So this is absorption law. If we replace the or operator with and operator with or, we can write it like this. So this is the absorption property. All of you got it? The next is a very important theorem, De Morgan's theorem. This theorem you will use it frequently. Is x or y all complement is equal to x complement and y complement. Similarly, we can replace the or operator with and operator with or. Then x and y, the whole complement, is equal to x complement or y complement. This is very important. Next theorem is the consensus theorem. Here, if a variable appears in complement and uncomplement form, the variable associated with that variable, that is y set, will have another term, right? Combination of those two terms like y and z. This is like a redundant term. So you can eliminate this. Then it will be x and y or x complement z. This thing also we can replace or with and with or. Then it will be x plus y and y plus z and x complement plus z. Answer will be x plus y and x or z. You can put some values and check the LHS and RHS side. So these are the various important properties of switching function. I hope all of you understood the properties. Now let's move to the canonical forms. How we can represent the switching function uniquely? We can represent it using the canonical forms. There are two forms, sum of products and product of sum. In canonical forms, there are two important terms which you need to keep it in mind. That is min term and max term. Min term is the product term in which all the variables will appear either in complement or uncomplement form. For example, x, y complement z or x complement y z. Next is the max term. That is the sum term in which all the variables appear either in complement or uncomplement form. X plus z. Then sum of products. This is one such type of canonical form. Here, this is the sum of min terms where the function output will be 1. Where the function will be 1. QAS is the product of sums. And this is where the function will be 0. So these are the two types of canonical form. One is the sum of product, other one is the product of sums. Now I will show you an example. Here the switching function is x and y or z com. Write all the possible input combinations first. This is x and y or set complement. This will be 1. Now, in term is here you can represent minterm with small like 0. So till 7. Then max term. Then SOP, that is the sum of product, sum of minterms. That the function is 1. So here the 1 comes here, 0, 2, 4, and 6 and 7. So n0 plus n2 plus n4 plus 6 plus 7. So how we can write this? Dash y set dash 6, 7. This is sum of product. Now how we can write the product of sum? Product of sum, that will be the complement of SOP. Write the product of sum format. So here it will be the product of max terms where the indices of function when function will be 0. What are the max terms? Max terms are M1, M3, M5. So how we can represent it as product of max terms? Is product of max terms. M1 dot A dot here. So here the max terms, here we consider one as variable complement. We'll take the prime. So here x equal to 0, x complement equal to 1. So 0 x plus I plus z 1 equal x plus y plus z. Similarly, here x complement plus y complement plus z complement. Then how the product of sum here will be x plus y plus z x plus y z complement x complement y plus z complement. This is the POS form. This one is the SOP form. SOP is the sum of midterms where the function is 1, and here the product of sum, that is where the function is 0. That will be M1, 3, M5. Is it clear, everyone? Now let's start the problem solving session. So here is the first question. Which one of the following is the idempotency property of switching algebra? Here x is a switching variable. The options are x or x complement equal to 1, x or x equal to x, x or xy equal to x, none of the above. You can post your answers in the chat box. Yeah, option B is the right answer. Idempotency property of switching algebra. That is x or x equal to x. If you are doing any operation or and on the same variable, then output will be the same variable. So if you are giving a value 0 for x, then 0 or 0 equal to 0. If you are giving 1, then it will be 1. So that is equal to x. If you replace or with and, then also x and x will be x sub. So this is the idempotency property of switching algebra. So option B is the correct answer. Idempotent law states that a variable would remain unchanged when it is and or odd with itself. The next question is find the equivalent expression of x and y complement or x complement y side the whole complement. Options are x or y complement or x complement or y or z. Option B is x complement y or xy complement z. Then option C is x complement or y or x or y complement or z complement. Option D is x complement or y and x plus x or y complement or z complement. Yeah, option D is the correct answer. So here, uh, this is Hall complement. So you can apply De Morgan's theorem. That is A is xy complement here. B is x complement yz. So then it will be like A complement and B complement. So here xy complement, the whole complement, and x complement yz, that will be whole complement. Then the final answer will be x complement or y and x or y complement or z complement. All of you got the answer? Do I need to solve and show you? Yeah, most of them got the correct answer. Next question is, consider the switching function x complement z or x z complement or x complement y complement. Find the value of the function when x equal to 1, y equal to 1, z equal to 1. Second part, when x equal to 1, y equal to 0, z equal to 0. These are the options. All of you got the answer? For the first part, you will get 0. Second one, you will get option B is the correct answer. Here, if you look at this function, this is x complement, z complement, y complement. So definitely it will be 0. And y equal to 0, z equal to 0, x equal to 1. This term will be 1. This will be 0. This will be 1. This will be 0. So second part question, the answer will be, the value of the function will be 1. So B is the right answer. Next question is, sum of product representation of the switching function x or y or z is, you have to write the sum of product representation for this function. How to find the SOP representation? SOP is the sum of minterms where the function is 1. Option A is the right answer. All of you got the answer. Do I need to work out and show you? So here it's a three variable function. First, you have to write all the input combinations. And the switching function is x or y or z. First one it will be 0, the rest will be 1. Now sum of product, that is sum of in terms where the function is 1. It will be total 7 midterms are there. Sum of all the midterms. So option A is the right answer. Next question is convert the following decimal number to binary. So here this is a decimal number, radix is 10. You have to convert it into binary number system. The value is 20. How it will be? You have to divide this 20 by 2 and track the remainders. What is the answer? Yeah, 10100. That is the correct answer. So here, using the positional format, it will be 1 into 2 raised to 2 plus 1 into 2 raised to 4. That is 16 plus 4, which will be equal to 20. The rest of the things, it will be 0. So the binary representation of 20 is 10100. The next question is, consider the XOR operation x equal to y XOR z. Then which one of the following is correct? Z XOR x equal to 0, x XOR z equal to 0, x XOR y XOR z equal to 0, x XOR y XOR z equal to 1. Which of the following is correct? Here there is one assumption given, x equal to y XOR z. Here the condition is given, x equal to y XOR z. The option C is the right answer. All of you got it? That is x XOR y XOR z equal to 0. All of you got the right answer? Do I need to solve and show you? Here, x equal to y XOR z. This is given. Now, if you look at option C, that is given x XOR y XOR z equal to 0. So instead of y XOR z, we can substitute as x. So x XOR x equal to 0. That is if, so means if x equal to 0, then 0 XOR 0, that will be 0. If x is 1, then 1 XOR 1, that is also equal to 0. So option C is the right answer. X XOR y XOR z equal to 0. All of you got it? Next question is, which one of the following set of operation is functionally complete? Is it and or NAND or not? Yeah, option B, NAND is the right answer. That NAND operation is functionally complete. We can represent not with NAND, NAND of A comma A, that will be the whole complement, which will be equal to A complement. So this is the NOT operation. How we can represent AND with NAND? That is NAND of AND AB, NAND of AB. A dot B complement dot, this is NAND of this term into this term. B complement the whole complement. So based on the De Morgan's theorem, how we are applying De Morgan's theorem? Here, this is A, this is B. So AB, the whole complement, that will be equal to A complement plus B complement. We have applied this theorem only here. Now, this will be complement complement. It will A dot A and B plus A and B. This will be A and B. Now we will see how we can implement OR with NAND. For OR, it will be NAND of NAND A comma A, NAND of B comma B. So here it will be A complement B dot B complement the whole complement. Here also, this is A, this is B. Before that, A dot A will be A, right? So you can represent it. Now we are going to apply the De Morgan's theorem. So here, A is A complement, B is B complement. So say this is also De Morgan's. Now this will be A complement A, B complement of complement B. So A or so using NAND, we were able to implement not and or. So this is a functionally complete operator. So option B is the right answer. So the explanation, this only I have shown you how we can implement not and or with NAND gate. Next question is find the decimal equivalent of the of this binary value. Dash is equivalent to which of the following number in base 10. So you have to find the decimal representation of this binary value. Solve this and tell me the answer. What is the answer? The option A 13.25. Here 1101, that is 1 into 2 raised to 0, 1, 1 into 2 raised to 2, or 1 into 2 raised to 3, 8. 8 plus 4 plus 1, that will be 13. And here this will be 0.25. So the final answer will be 13.25 in decimal format. Option A is the right answer. The next question is, which of the following binary equivalent to 432.375? This is the decimal representation. You have to convert this decimal representation to binary number. You have to divide by 2 and so you have to divide by 2. Here the answer is C. 110, 110,000.011. All of you got this answer? Okay, moving to the last question. Which of the following octal number equivalent to this binary number? Option B is the right answer. All of you got it. So you have to multiply with 8, 1 into 8 raised to 1, 1 into 8 raised to 2. So you will get this value, B. Sorry, this is, you have to convert it into octal, right? Then you need to group it. So here it will be 6, then 5, then 6. Here it will be 1, only 2 digits are present. You can add 1 0 at the end, then it will be 4. So 56.14. So option B is the right answer. This is to convert it into octal. If you want to convert it into decimal, then you have to multiply with the positional values. For this question, option B is the right answer. With this, we are coming to the end of this session. If you have any questions, you can post it in the chat box now. This is the reference. Okay, if you want me to explain any particular topic or solve any particular problem, you can post it now, or you can also post it in the Google forum. I will do it in the next class. Okay, this is one of the reference. If you don't have any questions, then we can wind up the session. Okay, thank you.